Hello students, welcome back. In the last session we have discussed about the black box testing. In today's session we will discuss debugging. So debugging is the process of removing bugs from the program. So let's start with debugging. Debugging is the process of trying to fix a program that you already know does not work as intended. As I've said, debugging simply means fixing the errors in the program. In other words, it refers to identifying, analyzing and removing errors from a program or from a software, and this activity begins after the software fails to execute properly, or you can say this activity begins after your software or a program fails to execute properly, and it concludes by solving the problem and successfully testing the software. So debugging is the process of removing the bugs. Now, how the word bug came into existence, or how the problems in a software is called as bug. So there is a fairy tale behind the use of a word bug for a software problem or a software error. So there is a charming urban legend about how the process of fixing flaws, that is problems in software, came to be known as debugging. So how the solving the problems in the software, it is known as debugging. So there is a story behind it. You can see a photo here. So the photo below, it is of September 9, 1947. It is a page in a laboratory book from the group working on Mark II Aken relay calculator. So they were working on the relay calculator at Harvard University, and there was a moth in the relay when they were working with the relay calculator. So there was a moth in the relay, you can see it here, panel F, moth in relay. So there is a photo of the moth. So moth, it is a bug, or you can say it is an insect from the butterfly family, and they removed that moth from the this Aken calculator, and it is said that from then it is called as debugging. They removed a moth. Moth means a bug. They removed a bug from the that calculator, and they call it as debugging, removing the bug. So some people have claimed that the discovery of that unfortunate moth trapped in the Mark II, as we have seen in the last photo, the moth which is trapped in the Mark II, led to the use of phrase debugging. That led to the phrase debugging. However, the word first actual case of a bug being found, it suggests that the less literal interpretation of the phrase was already common. So the wording below it, you can say first actual case of bug being found, that says that the less literal interpretation of the bug, the phrase was already common. So debugging was already used in previous cases as well. Okay, runtime bugs. So runtime bugs can be categorized along two dimensions. So runtime bugs can be categorized into two different dimensions. First, it is overt to covert. So an overt bug has obvious manifestation. For example, when you have an overt bug in your program, the program crashes or takes far longer to run than it should. So when you have a bug that is an overt bug, the program crashes in between or it takes far longer to run than it should take usually. You might have come across this bug, overt bug, when you execute your programs. The program will crash at some point and the program stops execution there. So such bugs you can say are overt bug. For example, if you have a statement where you are assigning a string value to an integer variable, in such cases the program stops at that point and it crashes. Or even if you have a loop, that is infinite loop, which is created in the program because of some mistakes in the condition checking, then you can call it as overt bug. Overt bug has obvious manifestation. That means you can see the bug in the program. It actually shows you there is some problem in the program. That is why it is called as it has a manifestation. It shows that there is something wrong in the program. So that is an overt bug. A covert bug has no obvious manifestation, means it may not show you that there is something wrong in the program. The program may run to conclusion with no problem other than providing an incorrect answer. Now in case of covert bug, the program may execute properly without crashing, without having any problems at the time of execution, but the output of the program at the end may not be proper. So such type of bugs can be categorized as covert bug. So program will execute, it is fine, but at the end if you check the output, you may say the output is wrong. So there may be something wrong with the output. For example, if you are executing a program that is factorial program, and in the factorial program in the for loop, if you have a statement that is fact, that is f is equals to f plus I. If you have the statement inside the for loop, when you are calculating a factorial, f, that is fact, is equals to fact plus I, this statement, it is fine and the program will execute and it will produce the output. But the problem here it is, if you look at the statement, we are not multiplying here, we are simply adding. But whenever you are trying to find a factorial, it should be multiplication, right? So in such cases the output is wrong, the produced output may be wrong, but the program will not crash, program will execute properly. Such type of bugs are called as covert bugs. And as you can see, covert bugs are very hard to detect. In case of overt bugs, the program will stop immediately and you know that there is some problem with the program. But in case of overt bug, covert bug, you don't know there is something wrong in the program. You will get to know there is something wrong in the program only when you verify your output. Otherwise you may feel like it is executing and it is producing the output, but the output which is produced by such type of bugs, it is the wrong output. Then the second type, it is persistent and intermittent bug. A persistent bug occurs every time the program is run with the same input. Now in case of persistent bug, it occurs every time, as the name persistent, it occurs every time the program is run with the same input. For the same input, the bug occurs. In case of intermittent bugs, these occurs only some of the time, even when the program is run on the same input and seemingly under the same condition. Now in case of persistent bug, it occurs every time when we pass the same input. For example, if we have a statement that is C is equals to A divided by B, A divided by B. If you pass the value of A as 10 and value of B as 2, so it will produce the output properly, there is no problem with the program. But when you pass values like A is equals to 10 and B is equals to 0, then there is a problem and the program will not produce the proper output. Every time you pass the same input, that is A is 10 and B is 0, or you pass 0 for the variable B, it will produce a problem. It will produce a bug. So that is why it is called as persistent bug. Occurs every time the program runs with the same input, but if I change the input, it may run properly. But when I pass the same input, it will generate a bug. In case of intermittent bug occurs only some of the times, not every time it occurs, even when the program is run even with the same inputs and seemingly even in the same condition, then it is called as intermittent bug. And as it suggests, you can see persistent bug which is occurring every time with the same input. It is very easy to detect such bugs and it is very easy to debug such bugs in the program. But if your program is having an intermittent bug, it is very hard to detect such type of bugs, because these bugs are not occurring every time. It is occurring sometimes in the program, and sometimes the program is working fine without any problem. So in such cases, what is the problem with the program? It is very hard to detect, and such types of bugs are very hard to detect and debug. For example, in case of intermittent bug, say if you're working on the computer and suddenly your computer hangs up, so nothing is working, then what you do, you restart the computer, and after restart the computer, again it is started working fine without any problem. So that type of bug occurs, your computer hangs up not every time, sometimes in between it hangs up. So such type of things are very hard to debug. So you don't know what is going wrong, so that your computer is hanging, and it is not happening every time. So next time you restart the computer, and when you work on the computer, it is working fine without any problems. But sometimes it is hanging and it is giving problems. So such type of bugs are very difficult to debug. Okay, these are two categories of runtime bugs. So good programmers always try to write their programs in such a way that programming mistakes leads to bugs that are both overt and persistent. So good programmers should always write their programs in a ways which leads to overt and persistent bug, not covert and intermittent bug, because covert and intermittent bugs are very hard to detect and debug, and this is often called as defensive programming. When you write program in a way which generates only overt and persistent bugs, then it is called as defensive programming. Okay, in today's session we have discussed what is debugging, what is bug, and runtime bugs. We have discussed two categories of bugs as well. So we will stop here today. Thank you.